Hello there, this is Meng from University of Delaware. I will introduce our work, our multimodal transformer robust to missing modality. This is joint work done with Qian and David from Snap, Long from Google, and my advisor, Professor Peng. Existing work in multimodal transformer generally focus on designing new architectures for multimodal fusion or developing strategies for large-scale pre-training. Recently, some work discussed the transformer robustness against noisy input. However, an important question has not been investigated. Are multimodal transformer robust against missing modality? This question is crucial for multimodal learning since the modality might be missing in the real-world scenario. In this paper, we will empirically evaluate the transformer robustness against the missing modality. We conduct experiment on three datasets: multimodal MDB, UPMC Food 101, and headphone means. We use VILT as a transformer model because it represents a typical design of a multimodal transformer. Next, let's see some observations. We observe that the transformer model is not robust against missing modality, as can be seen in the figures. When dealing with model incomplete data, transformer performance dropped by 44 on MDB and 28 on Food 101. And surprisingly, transformers' multimodal performance is even worse than the unimodal one. Next, since fusion is an important topic in multimodal learning, we also conduct experiments to see the effect of fusion strategy on transformer robustness. Unsurprisingly, we observed that the fusion strategy do influence the transformer robustness. What surprised us is that the optimal fusion strategy is dataset dependent in the presence of missing modality. For example, when tested with full modality, either early or late fusion are equally good on both datasets. But when testing with missing modality, it's clear that the Food 101 prefers a late fusion over early fusion. Based on our observations, we propose new methods to improve transformer robustness and attain the optimal fusion strategy on different datasets. First, let's look at how we improve the robustness. We argue that the main reason transformer model fails to handle income data is due to the data discrepancy between training and testing. During training, transformer model never saw model incomplete data. So a straightforward way is to train the transformer jointly with incomplete data. In particular, we formulate the training with complete and incomplete data as multitask learning. Each task is corresponding to one type of training data. For multimodal fusion, we propose to learn a policy to attain the optimal strategy. In specific, we will first assign each layer of fusion parameter alpha, which indicate fusion or non-fusion at current layer. Then we can obtain a fusion strategy by sampling from the fusion parameters. We jointly learn policy and model parameter through bi-level optimization. The inner level will optimize the model parameters, and the outer level will optimize the policy parameters. For more details, please refer to our paper. Here are the experiment results on robustness against missing modality. We can see that our method ensures the transformer's multimodal performance is always better than the unimodal one. And in general, our method yields more robust transformer models. We also visualize the learn policy for different data sets. We see that on MDB, the late fusion is preferred, and early fusion is preferred on headphone means. Finally, we compare our method with a simple baseline, which is training with random modality missing. And the results shows that our method yields the best result. Thanks for your attention.